Ayo, today I'm going to show you how to make a rack and pinion gear system in Fusion 360 and design it so that it can actually move up and down within your model file. So let's get started. Now Fusion actually has a script that allows you to create gears, so you can go to utilities here, click add-ins, and then scroll to the bottom where you see spur gear, click run. It should open this dialog and you can edit all your parameters. So I'm going to change my module to 2. I'm going to change my number of teeth to 16. Fill the radius down, make this smaller, and then get rid of the hole. You can see that pitch diameter, you can't actually change it manually, but it's just a product of the module times number of teeth, so you can edit these two to change this. When you're happy with this, hit OK. And you can see it populate in your design file. And at the bottom here, you'll actually see all of the steps that I went through to create this gear. So you can see the sketch it made of the main circle, the extrude, the sketch of the tooth, and then the circular pattern and all that. And you actually modify any of those if you would like. Now, what I'm going to do first, I'm going to press M to hit move, click this body, and I'm going to rotate it about the center axis. If I turn the origin on really quick, and I'm going to rotate it by 360 divided by the number of teeth I have divided by 2, and you'll see why I do that in a second, but I'm going to hit OK. And then I'm going to go to the sketch of the tooth. I'm going to select the shape, and I'm going to hit Control C. Exit out of that sketch, create a new one on the same plane, and then I'm going to hit Control V, and you can see that it brings the same shape to this new sketch, and I'm going to translate it just to the other side, so it's facing the correct direction. So I'm just going to translate it by the diameter of the circle, which was 32. Obviously it has to be negative, so it goes the other direction. And then I'm going to add a little bit of tolerance, just so there's some space between what will be the rack. So hit OK. And then I'm going to add a rectangle, so I'm going to make a line in line with this. Let's make it, I don't know, 30 millimeters long, and then we're just going to connect these into a circle, into a rectangle. So we're going to go 4 this way, we're going to go 4 this way, and then we're going to connect this. Okay, now we're going to make more of these teeth, so we're just going to create a rectangular pattern, select the shape, and then we're going to go down here, quantity, how many do we want? Maybe we want 4. And then for the distance, we need to make the distance, so our module, and then we're going to multiply that by pi. And the reason for that, I also have to make it negative so it goes in the other direction. But the reason we multiply by pi is because the teeth on the gear are around the circumference of the circle, and obviously circumference is pi d, so we're just multiplying by pi here to get the correct spacing. Now, anyways, maybe I can fit 5 on here. Just about, but we'll stick with 4. So we're going to hit OK, and then we're going to exit out of this sketch and extrude this shape. And I believe the gear was 4, so we're going to extrude it by the same amount. And now we have both of our bodies done. So what we're going to do now is we're going to make this body into a component so we can actually make the joints. We're going to unground the original spur. We're going to create a new body which is going to be the base. Or we're not going to do it inside. So create a new body. Call it base, and then we're going to ground this component. And then we're going to add our joints. So we're going to add build joints. We want to select this and the base, and then we want to make it a slider joint. And then we have to select the direction of motion, and there we go. Now it moves up and down, or it will. We'll hit OK, and then make one more joint for the pinion. We're going to make this a, well, link it to the base first, then make it a revolute joint about the central axis, and you can see that it spins. Hit OK. And now the last thing to do is to link these two components, because right now they don't move with each other, and that is not what we want. So we're going to add a motion link. We're going to select this joint and this joint. Let me turn this animation off for a second. So with this motion link, what we want to do with these distances is link how much the rack moves with how much the rotor, or not the rotor, but the pinion will spin. So in order to do that, we know that the distancing is basically equivalent. So we're going to multiply this by pi times the module of one of these gear teeth. And then for the angle, which is of the revolute joint, we're going to have 360 divided by the number of teeth. And this will link it so that when we move the rack one tooth, the gear also moves one tooth. And then we're just going to reverse it so that they spin in opposite directions. So you can see the animation here. I hit OK, and now when we move this, you can see that they move in unison. So everything seems to be working properly. And the last thing you can maybe want to do is constrain the motion of the slider joint to however many teeth you want it to move up and down. So let's say we want it to move down only one tooth, so negative pi times module, which is 2, and then the minimum that we want it, the maximum we want it to move is maybe pi times module as 2 times maybe 4. And now when we move it, we get constrained in the motion. Anyways, that is pretty much it. You can obviously extend this and then do whatever you want, but that is the basics of how to create a rack and pinion gear system. You can print this and actually see if it works properly. Anyways, see you in my next video when I inevitably do something. I don't know what it will be. Bye-bye.